Good afternoon, good morning, good evening to everyone who has joined the webinar so far. And welcome to this webinar on the second AI for EO challenge, AI for Sentinel-2. Today, the aim of today's webinar is to give you a little bit of an insight about the challenge itself, and also for any of you that are already participating in the challenge to answer any of your questions. So we'll start with a general introduction to the challenge. We'll show you also how to use the EuroDataCube resources that are put at your disposal. And then if you have any questions, you can already put them in the chat, or towards the end, raise your hand so we can unmute you and have you ask it live. So let's get started. So AI for EO, for those of you who haven't been in this come on. Wait. Okay. So for those of you who haven't been with us yet for the first challenge, what is it that we do? So AI for EO is an initiative of the European Space Agency and specifically of the PhilLab, where they develop new and innovative approaches to working with Earth observation data and acquiring Earth observation data. And the idea of this initiative is to build a community that reaches out to the AI community and let the Earth observation and the AI community mingle with each other to find solutions for grand societal challenges. So we're building a platform that is dedicated specifically to running 3 to 4 month challenges that you as the AI for EO community can participate in, where you can win prizes, can come up with new algorithms, new techniques to handle Earth observation data for a specific problem. We're organizing at the moment 3 challenges. The first one was on air quality and ended in June. And then the second one, which will be the topic of today, is on the use of Sentinel-2 for land management applications, in particular for looking at features at a resolution lower than the Sentinel-2 native resolution. Behind the AI for EO initiative are several companies. So when you get an email from us, or when you email us, you might get a response from Planetech, from Synergize, from G-Matics, from EarthPulse, from Space Tech Partners, depending on which what your question is about. So just so you know, if you see any of the email addresses from our partners. So in brief, you will get a more in-depth insights in a bit. The second AI for EO challenge has started on the 14th of June and will run until the end of September. So that gives you 3.5 months to find a solution, to fine-tune your solution for using Sentinel time series for feature enhancement, specifically for land management purposes. And of course, as you may have noticed already, or not yet, and are looking to join the challenge, you can find all of the information on platform.ai4eo.eu. The most exciting part, I would say, in participating in the challenge is that you're eligible for a prize pool of over 70,000 euros. We, at the end of the challenge, select 4 winning teams based on qualitative criteria from how good your solution responds to the challenge itself, and the metrics that are calculated, but also some qualitative metrics related to the innovativeness of your solution, the contribution to open science, the quality of your documentation, for example. So depending on your place or your ranking, you get a certain amount of points that you can then use to go into the price catalog and select from the prices that you like best. So we don't give you a particular price. You and your team can decide which price works best for you, whether that's mentoring for setting up a business, whether that's more technical support, whether that's cloud resources, some data, or some software. And for this challenge, we have two big sponsors. We have Eltree Harris, who's handing out some software licenses for Envy, and Planet, who is giving access to their Planet dataset. So what is this challenge about? The goal of the AI4Sentinel2 challenge is to map arable land using Copernicus Sentinel-2 data. And to specifically extract features at a resolution smaller than the native 10 meter pixel resolution. And why is that useful for us to really find a solution to? It's because in a lot of countries in Europe and beyond, agricultural fields may be narrower than 10 meters, or you may want to find specific features on a field, like buffer strips, for example, that are narrower than those 10 meters, but for which the free and open data from the Copernicus Sentinel-2 satellites can come in very handy. So if you have a good solution or have something in mind, give it a try. Use your AI knowledge to find a new technique for detecting these features. So I hereby conclude my part of the presentation and will hand it over to Davis from Synergize, who will go more into depth about the technical part of the challenge. If you have any questions that aren't answered in this webinar, you can always reach us at support@ai4eo.eu or on the forum on the AI4EO platform. So thank you. Davis?
Yeah, hello everyone.
Hello.
My name is Davis from Synergize. I'm going to start to share my screen. So my plan is to show you sort of hands-on what the challenge is about, what Anne-Catherine has shown you. And in particular then, so just give you an overview, mostly the content that is already on our platform. So you can see, you probably, the ones of you already had a go. This is our platform and this is the current challenge. So you see just an overview of this Sentinel-2 enhancement challenge, which was created in collaboration with TUM DLR. Very important, as mentioned, the rules. So here you will find what Anne-Catherine mentioned, how basically what we allow and what we don't allow, and what basically will be considered for the prices. So how the final score based on qualitative and sort of quantitative evaluation of your solution is created. So this is the page, the reference page for, again, the rules. If you have sort of questions, of course, if something is not clear, we have a forum section where you can ask anything, and we are basically here to support you. Here you have the list of prizes, which Anne-Catherine summarized already, and I will be focusing on the data page. So once you will sign up, you will be able to see this window, which contains basically the main links for download, and I'm going to talk about this in a few seconds. And this page gives you sort of an overview of the challenge as mentioned. So we want to enhance the resolution of Sentinel-2 time series. So the input to this challenge is Sentinel-2 multispectral time series at 10 meter resolution. Maybe I can zoom in so you can see a bit better. Over a 6 months time period, so from 1st of March to 1st of September 2019, which captures the main growing season for crops of a cultivated land. This is L2A product, so bottom of atmosphere, and we provide the 12 multispectral bands, all resampled at 10-meter resolution. So the bands which are originally at 20 and 60 meters are also resampled at 20-meter resolution, at 10-meter resolution, sorry. And we also provide the scene classification layer and cloud masks. So this is the input to your algorithm. And what you have to generate is a cultivated land binary mask at 2.5 meters. So we are searching for a 4 times improvement of the resolution. But again, we are not looking at sort of super resolving the images. We want to get a binary cultivated map. Areas of interest. So Slovenia is the main area of interest, and we split this area and sort of the neighboring areas into 125 bounding boxes. Of these, 100 are provided as training data, and 25 are the ones used for testing. So you will submit your solution for those 25, which we evaluate to get the quantitative scores. So the resolution, as mentioned, the size of this is 500 times 500 Sentinel2 pixels, which result in a 2000 times 2000 cultivated land map. So the output will be 25 images of 2000 times 2000 pixels. As mentioned, so the metrics used for the quantitative evaluation of your method is based on the Matthews correlation coefficient, which is particularly suited to quantify algorithms where the classes are very imbalanced, which is the case for this task, where we have many more 0 pixel sort of non-cultivated land as opposed to cultivated land pixels. So this is very suited in sort of evaluating how good you are to find those cultivated land pixels, in particular at this sub-pixel resolution. So what we actually added to sort of this sort of basic formulation of MCC is the use of weights. So each pixel is weighted differently. And this is done again to enhance the basically what we would like you to get right are the small parcels. So what we do, we weight more those small parcels, and we weight sort of less bigger parcels and also pixels coming from the background. So this is the rationale behind this weighting. And you can find the formulation for this weighting in the notebook. So everything, how the MCC is computed and the weights are shown and provided in the notebook. So on your training data, you can simulate the evaluation score, which is used for evaluating the test data. So the leaderboard formation, as mentioned, you will submit your 25 images with your prediction. And we split these into 2 sets. One is the public subset and one is the private subset. So during the challenge, we will show the test score on the public subset, while once the challenge will close, we will take the private score associated to your best public score. So this is done to sort of avoid you overfitting to basically your submission, so to the public subset that you see during the challenge. And as mentioned, then these scores will be 75% of the final score in awarding the winners of the challenge. So this is then probably the section that you'd be mostly interested in, how to get started and where are the main resources. So we are happy to announce that from this challenge, we also provide some computational resources if you need it. And in particular through the EuroDataCube resources. So there is a link here, and I will show you in a second how you can apply and basically following through how to get to your notebook. And alternatively, you can use your personal resources. Here are the instructions to get started setting up the same environment which is provided in the EuroDataCube. So either participant that decides to use the EuroDataCube or use their own resources have the same starting point in terms of Python environment and notebook, of course. And so what you'd have to do is basically pull the Docker image from the EuroDataCube, which is the same used to set up your environment. And then whether you have an NVIDIA GPU available or not, you can follow this instruction to give access to your Docker image to the GPU, and you can start and access the environment following then these commands, and then you can access the Jupyter Lab environment where you can execute your notebook and access the data. For downloading the data, we'll show you again in a second through the notebook. There are two main ways for the training data. So we recommend the use of the APIs to download the images and the reference data for the 100 training eopatches. Otherwise, we also provide direct link to the entire eopatch, to the entire dataset in the form of eopatches, which has the size of 12 gigabyte. And you will see then the direct link at the top of the page. And this is for the training dataset. You have these two options. For the test dataset, there's only one option, which is through direct link, which again is provided at the top of the page, which is about, I think, 2 gigabytes. We can show then from here is around 2.7 gigabytes, and this is the only way you can get the input images for the test eopatches, and these are the ones where you will generate the prediction and submit it for evaluation. So as mentioned, direct link to the testing. Then you also have the direct link to the training dataset if you chose to download directly the entire dataset. Then here we have the link to the GitHub repository containing the starter pack. And here there's a link to request the GPU-based workspace on the EuroDataCube platform. So now we'll show you how this works. So you click on this link and you will be redirected to the EuroDataCube. So you need to sign up first if you haven't. So there's the usual sort of sign up form, your email, and few more details. And then you will land into the AI4 challenge, where you agree sort of to the terms and of service for the EuroDataCube, Sentinel Lab, and GeoDB, which are the APIs used to download the images and the reference data. So then you click to participate, you will be notified, and usually after a few hours, you will get access to the platform. So if you go through your dashboard, then you will see your EOXCube instance with the GPU plan activated. Here some stats of the status of your instances, and you will see that you have Sentinel Hub free trial activated already and GeoDB free trial account activated already. So if you go through the EuroDataCube, these two accounts have been already activated for you. If you use your own resources and you don't have them already and you want to download the data through the APIs, you have to create two separate trial accounts. While again, for the EuroDataCube, they're already set up for you. So then I can access my instance. So in this case, you will see only one option. And now I will access my workspace on the EOX, where you will see a read-only. Now it's loading, so it's finding the resources for you. I might have already. Let's see, I have my environment already set up. Okay, then we wait. Okay, let's go back. So now the resources are being reserved, and I will show you in a second, as soon as I get the resources, your landing page on the platform. If you have any question until now, please fill in the Q&A, and of course, we'll be very happy to answer. And I'll be done very shortly, as soon as we get to the environment, and I will show you. Actually, I'll get started on the notebook. I'm here, so we don't lose time. This is the notebook you will find on the EuroDataCube, and you will find on the GitHub page. If you chose to use your own resources, then you just can clone the repository and get started. Again, here you have a short list of requirements, which again involve the creation of the free trial accounts for Sentinel App and GeoDB if you were not to use the EuroDataCube resources. Otherwise, they're already set up. And you have direct links to basically create them and get started. So then you fill in your credentials for these two APIs. And whether you are on ADC, you would use the GeoDB client as is. Otherwise, you'd specify your client ID credentials and secret, since, again, you're using your own resources and you need to specify them here. So let's check if my environment is ready. Not yet. Okay, then we continue with the notebook. So the notebook is separated into mainly three parts. So the first is about the data, how you can retrieve it and sort of have a look at it, and also check that the download is correct. So whether you download through APIs or through direct link, there's some code to check the correctness. Then there's some code showing how to generate. So this is the table of contents, how the data overview, the validation metric. So again, how to compute the MCC and the weights. Some tips on the data processing and the submission example. So there's a dummy example how to get your predictions, and you will get some files out of this notebook which you can directly submit to the platform and get the score. So I will very quickly go through the notebook. So it should be hopefully self-explanatory. But again, if you have questions, use the Q&A session here to ask them, or of course you can ask on the forum. So these are the 100 training locations, which again are downloaded from GeoDB. And then for each of these, we are going to download the 12 bands, Sentinel-2 bands, the send-to-core string classification, is data binary mask, which tells whether the pixel has valid data or not. And then we have the cloud probability and cloud masks derived from S2 Cloudless. So these parameters you cannot change. So these define the data set. So you cannot change the interval of resolution. So this has to stay as is. And we are basically parallelizing this workflow. And you will get, so here we have the task which downloads the image. You can see an example. For one location, we have the Sentinel2, the mask, the scene classification, and the cloud probability. So you can derive then, for instance, number of frames, of valid frames through the 6 months period for each eopatch by combining the scene classification mask and the cloud probability mask. So we have the task to retrieve the imaging data. Here we have the task to retrieve the reference polygons. So for the training patches, we provide the reference data to use in your machine learning algorithm, which are stored in a GeoDB table. So here you have again the names of the table, which are not to be changed. And here you have an illustration how a reference polygons look like for an eopatch, for the same eopatch. So what we do, we download this. You have then the instructions or sort of the labels of what each label of this mask actually is. So this is a combination of two different sources. One is land cover and one is crop declarations. And we provided both sort of reference data for each pixel, even though we are only interested in cultivated land, so that you can use this information, for instance, to better sample your input samples to the machine learning algorithm. So for instance, there will be a lot of pixels in the not cultivated land, but you can decide which ones to focus more depending on the confusion that you will get. For instance, you might get more confusion with grassland compared to forest. So then you can use these labels to sample more from those locations, for instance. And similarly for the cultivated land that we provide, so we provide the mapping to each crop type to the cultivated land. So you can also use this information to better choose your samples. So this is the part that does this. So maps all these different labels to 0, 1. There's some notes here regarding sort of the nature of the land cover and the crop types. So there are some crops which sort of we cannot tell for sure which crop was declared, although it should be cultivated. So these parcels will not be used for the evaluation score. So we have this information and we won't use these pixels to compute the score. So then in training, you can also ignore these or not. So for the training part, this is up to you. For the testing eopatches, these won't consider. So these are mapped, I think, to label 2. So then you can decide how to handle this as you wish. So then we have the different EO tasks that do this part. So downloaded the cultivated, not declared, and also sort of all the labels. So we add to the eopatch this information and we map them to the binary mask. So then our eopatch now is populated with the bands, the masks, and the reference data, both in vector format and in raster. So these are the raster masks that you will use to train your algorithm. Now we put together, and this is an example of such mask. You can see very few sort of cultivated pixels compared to non-cultivated pixels, so very unbalanced. And then we put everything together to download the data for all the 100 patches. So here we are just parallelizing over the 100 patches. So we have workflow here, your executor that downloads all the data. And here you have downloaded the testing data again only through direct link. and then you can check the files both for the training and for the testing against their hash. So they've been hashed, the files, so you are sure that the download is correct and that you have the correct set of files to train and test your algorithm. Here you have the definition of the validation metric that you can use in training your algorithm. I won't go into much detail, but as mentioned before, is a function of the size of the cultivated land and how far you are sort of from the edge. So the edge will be weighted more because we want to get the parcels clearly separated, especially the very thin ones. So this is an example of weighting function. And the section of data processing, again, there's some possible steps on how to get started. Again, feel free to ignore. These are just some things that might be useful. For instance, sampling small parts, smaller batchlets for your algorithm. And this is just an example. Most important is the section on the submission. So here you have the instructions on how the submission file should look like for a valid submission. And they just create a simple threshold on the NDVI time series to create this dummy version. So here we just create a workflow that does this post-processing. Again, doesn't consider the training data. It's very simple, very dummy, but it showcases how the test prediction file should look like, and also it provides you with an example that you can directly submit, and you would get a score of 0.534. So this is also for you to sort of validate that the submission process works. And this is it. Now I'll just go back to see if we get the resources, so I can show you. Here we go. So this is the landing page to the EuroDataCube. Once your resources have been allocated, you have, I think, up to 100 gigabytes of workspace, so to save your files and do your work. So this will be a read-only folder for you with the material. So what you have to do is basically go on the AI4 README file, which is here, where you have basically, again, a simple overview. And by clicking here on the starter notebook link, you will open the notebook that we just went through together now, but you cannot execute it. So what you have to do is simply click on execute notebook, and this will make a copy in your workspace. So you just say, okay. And you will see it created the starter pack on your workspace, and now you are ready to execute. So now you can just go through each cell and execute the notebook. And this is it. So it should be very simple to get started using the EuroDataCube resources. And I'm done from my side. Please, if you have questions, we are here to answer them.
Thank you, Davis. Indeed, we had a question during your presentation from Christian Ayala. What are the differences between cultivated and not declared masks? I'll start with the first one.
Yes. Sorry, I didn't see the questions as I was checking only my screen. So again, we use the polygons for the cultivated land, so defining ones, only where we had crop declarations from farmers. So where we are sort of fairly sure that something has been cultivated there. And we found then some difference between these declared parcels and the polygons which is declared in the land cover as cultivated, but was not declared. So in this case, it's probably the farmer forgot to declare, but it also might be that there's no activity on it. And these separate class. So not being sure whether there's actual sort of agricultural or the land is cultivated or not, we separated this and put it in a separate class.
Yeah, so indeed,
does this answer your question?
Yeah, because the follow-up question was, are not declared crop fields also cultivated crop fields? And so if I understand correctly, yes, they can be cultivated crop fields, just haven't been officially declared.
Yes, exactly.
And then we also have another question from Aninda Goswami. How can we go from eopatch to numpy arrays?
Yeah, hello. So the eopatch is actually a collection of, so it's sort of a dictionary view to numpy arrays and data frames and geodata frames. So in the notebook, you will see the representation of eopatch, so it will have different features, but each feature is a numpy array. So basically what you have to do is just access this as a dictionary. So you can access eopatch data bands, and what you get out is a numpy array. So then you can do anything you want with this numpy array. You can save it directly as numpy array. So you can destructure this eopatch into numpy arrays or geodata frame. So it's a sort of convenient way, at least for us, to organize the data, so that you have time series and height, width, and channels sort of in a given structure. But you can access each feature as a numpy array and then do whatever you want with these. Hope this answers the question.
Okay, thank you. At the moment, we don't have any other questions, unless someone is still thinking. You can also always raise your hand if you prefer to say it instead of typing everything down. Or of course, if you can't think of it yet, but wanted to see what the challenge was all about and have some questions later, as we've shown you already. Okay, there's another question. What kind of neural network architecture can be useful? UNet?
Can give maybe some ideas. So UNet could definitely be useful. So typically UNet doesn't deal with temporal data. So in this case, you have a stack of Sentinel-2 images, and typically UNet takes a single frame into account. So you can sort of either train these with different time frames, or you can sort of modify. I don't know, there's some sort of 3D versions where you take also the temporal part into consideration. But this definitely would be a good starting point, because you will get a semantic segmentation output. So basically a classification for each pixel of your input image or time series. And sort of maybe as a pointer, this challenge is sort of inspired from the latest developments in multi-frame super resolution sort of architectures, where you have time series as input, and as output you have could be a single image, or again a time series at an enhanced resolution. So these architectures might be useful because they have already sort of built in, they can deal again with time series, because they use the information in the time series to enhance the spatial resolution. And yeah, you have to sort of adapt it to the challenge where the output is a binary classification map rather than an image. So that might be a good starting point.
Okay, maybe just while people are thinking of questions, I have a question for the people in the audience. Maybe can you raise your hand if you're already participating in the challenge? Okay, I see one person. Only one. So everyone else is looking into, should we participate? How does this work? Aaron as well. Very good. Nice. Are you having any troubles with working with the data, or you're still looking for a solution and haven't submitted anything yet? Do you need more support? Christian, Christian, I asked if you were already participating in the challenge. And we're getting some answers. So Xenia found it a little tough to get started. But yes, so the workflow is working. Aninda as well, not submitted yet, but will do so shortly. Christian, indeed, I believe you've already even submitted. And Aaron is researching architecture, so we are going to get some more submissions very soon. I hope this webinar then also helps with understanding how the Jupyter Notebook works and what the different parts are, and then knowing that you have access to the EuroDataCube resources, so you can run your workflow without needing your own server or anything. So, okay, well that's very good to know. In the meanwhile, do you have any other questions that you can think of? If not, we will close off over here, but don't hesitate to reach out to us if you have any question, or if you want to connect to the rest of the community, use the forum, and we wish you best of luck for the rest of the challenge. And we'll see you at the award ceremony at the latest. Bye.